Hi and welcome to video 11 on this video series on differential equations, Unit 4, Topic 2 of the Specialist Maths curriculum. And in this video we're looking at further differential equations, 13G from the Cambridge text, and we're now looking at separable differential equations. So dy dx equals f of x times g of y. We've just come out of some of the applications work, and so you've seen some fairly complex applications, but we're back to continuing on from the old dy dx equals g of y or dy dx equals f of x. And you've seen both of these parts. You have seen the simpler version of this, and you've seen the simpler version, super simple version of that. Now it's a combination of both and how we deal with them. The process is the same, so let's just have a look at some examples. Solve dy dx equals sine x over 3y squared if y equals 0 when x equals pi on 3. Now you wouldn't believe it, but this one's actually pretty simple. When we multiply through, we get 3y squared dy is equal to sine x dx. And then we can just integrate both sides, and the integral of 3y squared is just y cubed. And the integral of sine x is cos x, and I'm going to put a little plus c on that side. It doesn't really matter where I put the plus c, but I don't have to have it twice. Now we do know that at y equals 0, x equals pi on 3, and so we get 0 is equal to cos of pi on 3 plus c, and that leads us to cos of pi on 3 is of course a half, and I've just realized here the integral of sine x is actually negative cos. Oops, because when you derive cos you get negative sine. So we get 0 is equal to negative a half plus c, and therefore c is equal to 1/2. So there we have our c value, and we've solved and found a particular solution, which is y cubed equals negative cos x plus a half. And of course we could write this down as y equals the cube root. Maybe I'll even do the whole cube root, so on negative, let's even change the order, a half minus cos x cube root. So there you have it. That is the particular solution to this differential equation. Now let's have a look at example 2. So in example 2 it's another verify that question. Verify that y cubed minus 3xy equals c is a solution to this differential equation. So the way we go about verifying this would be to first of all recognize that this is not a separable differential equation. We can't separate the y's and the x's easily enough to be able to deal with it. So instead what we're going to do is derive this and show that we get that differential equation as we derive it. So this is a bit of implicit differentiation again, a bit of practice. d dx, this is our deriving of y cubed minus 3xy equals d dx of c, some constant. So when we divide the first term, dy dx of y cubed, we get 3y squared dy dx. And when we divide the second term, of course, we get a product rule. So be a bit crafty, make a little bit of space, and start dealing with our product rule. d dx of 3xy, this is our u and this is our v, and d dx of 3x is just 3y, and we also get d dx of y is 3x dy dx, and that's equal to 0. So now we add the 3y to the other side, and we get dy, well, let's write it like this, 3y squared dy dx minus 3x dy dx equals 3y. Factorise out the dy dx and the 3 in fact. 3 dy dx y squared minus x equals 3y. Cancel out the 3's and also change the order, and we get y squared minus x dy dx with well-placed brackets is equal to y, which is actually exactly what we have up there as required. So we could do as we need to do there to show that it works. So that's example 2, and we can deal with it as we need to. All the best.